Okay, probably all set to begin. We have quite a few people in here, just about to hit 200. So thank you everybody for joining. I very much appreciate it. I don't get to show up the reverse engineering features very often, so this is a pretty cool opportunity. For those of you that don't know me, my name is Matthew Snyder. I'm a field applications engineer here at Intrepid Control Systems. I've been working here for just under 5 years. I started working in our technical support department. A lot of you have probably worked with the great David Crockett, so I learned under him, which I'm very proud to say. I'd like to share a little bit about what I enjoy doing when looking at raw data that I just can't make sense of. So Vehicle Spy 3 offers a whole lot of tools for that and enables a lot of techniques for that. So that's what I kind of planned on covering today. One thing that I wanted to say is use the Q&A section, please, in the webinar. So what that's going to do is that's going to help me kind of shape the future webinars that I do and courses that I do on reverse engineering. So I want to know, so if you submit through the Q&A, these questions come to me, so it's not shared with anybody else. That's if you don't want to, if you want to mention that. But what I'd like to do is take the questions and kind of get a better idea of what you folks in the industry are kind of looking for, and maybe like things like types of signals that you might be after, or applications for reverse engineering, because I know it's not just competitive analysis. There are other reasons why you might be looking at data that you've got no potential decoding for. Things like writing drivers for third-party aftermarket features, things like that. So there's a lot of different things that I'm interested in kind of learning from this first cursory course, but that'll help guide the future courses and hopefully make them as helpful as I can. So anyways, started in the tech support department. I work as an FAE here at Intrepid now in the sales department. So I've worked with a variety of OEMs, seen a lot of different vehicles. I've got a fair amount of experience now, seeing different things. That's one of the cool things that Intrepid affords me. So let me just kind of jump into it here. So what I kind of hope to get into first is I'm not going to get into a real in-depth CAN overview. We offer trainings for CAN. I could spend 2 or 3 hours just talking about the CAN frame and different things that you can look for in the CAN frame. I'm not going to do that. Like I said, if you're interested in that, we offer trainings for those type of things. We offer basic CAN refreshers, advanced trainings, things like that. Just reach out to me. But that's not going to be the goal here. So the goal is going to be things that I consider when I first kind of approach a vehicle. So, just quickly, I'm going to go over some of the disclaimers. I think that's pretty important. But then I'm going to take a quick look at the physical layer of CAN, kind of what I look for under the hood, so to speak. We're going to cover the OBD and potentially gateways, things of that nature, things that you kind of used to see with the OBD port, and then things that you kind of see now going forward, because these things are changing. So after that, I'm going to briefly cover some of the tools that I use, physical tools, actual hardware, not just talking about vehicle network analysis tools, but actual tools of the trade on how you pierce wires and things like that. So I'm going to get into that a little bit. And then kind of the second big chunk of this will be Vehicle Spy reverse engineering features. So what you can actually do using the enterprise version of Vehicle Spy for reverse engineering, competitive analysis, that type of thing. So again, I could easily go for a full day talking about these things and these techniques. So I'm going to start today just by going through the basic features, the reverse engineering button in Messages View, for example, if you've used Vehicle Spy, and the basics of message editor is kind of the goal today. I find that the majority of what I do actually takes place in those two windows anyway. So we'll take a look at those, and then throughout this presentation, I'll be tabbing back and forth between Vehicle Spy. And then, so as we go, if you have questions, please submit them through the Q&A section. If I have time at the end, the plan is to answer these questions. If I end up talking through the whole hour, then I will definitely get back to you with all answers and that things of that nature. Plus, I've got my contact info at the end. So if you've got questions that are a little bit more in depth and you want to reach out to me directly, that's encouraged too. So my disclaimers, before you think about reverse engineering a vehicle, please be aware that it can be dangerous. Vehicles themselves can be dangerous. I probably don't need to say this to the majority of you, but tapping into wires, modifying, getting into the communication buses of vehicles is not is not something that you want to do on a car that is that you're going to rely on every day for day-to-day driving, especially not if it's a car that needs to pass inspections or anything like that. This should really be done on vehicles that are going to stay in the garage. Potential issues that you can run into, you can make the car completely undrivable. I've seen that happen. I've seen somebody try to fuzz an ECU's diagnostics and essentially completely brick their ECM, and their car had to go to the back to the dealer. Their warranty was void. It was a very costly repair. I can't remember how much it was, but all they were trying to do was try to see if there was any diagnostics that were unlocked and open to them, and they ended up really paying for it. So a little word of caution in that regard. Cars can require expensive repairs, but also communication is pretty important in vehicles, and different OEMs do different things, and in terms of how vehicles react to the detection of intrusions on different buses, changes in voltages and things like that. So just simple things like, like putting your car into, like, as everybody likes to anecdotally say, limp home mode, those type of things. You don't necessarily want to do that. So again, these type of things can be done on benches if you've got the equipment, or vehicles that you're not going to be driving. There's risk of electric shock. I originally had electrocution in there, but I was told that might be a little extreme. But especially on EVs, digging and poking into wiring harnesses, it's not just CAN that's in those harnesses. And then also, there might be high voltage things around you. There's fans that are moving that can grab these loose wires. You're opening up wires and potentially introducing contaminants that can cause problems. Please be careful. Take proper caution. Make sure that what you're connecting to isn't directly connected to the battery, and you're going to shock yourself. Please be careful in that regard. And modifying your vehicle generally voids the warranty. So keep that in mind. Don't do this on rental cars either. Rental cars, other people drive. So what do I kind of look for when I first open up the hood? I'm laughing at one of the comments, I'm sorry. So the real obvious thing that we look for with CAN is that twisted pair, right? CAN's a differential signal. So we look for that twisted pair. One note though, not all twisted pairs are CAN. There's a lot of times 20, 30, 40, 50, 60 different wires in one harness, and sometimes 4, 5, 6 different CAN buses in one harness. And you might have one twisted pair that looks identical to the other, but one might not be CAN. So one story about that, I was looking for a CAN FD bus one time, and I was so focused on the sensitivity of CAN FD. CAN FD is a lot more sensitive than classical CAN. You always want to ensure that you're terminating properly with split termination, using shorter runs of cables if you're actually tapping a CAN FD bus. And even then, you might have trouble without building a real harness. Well, I was focusing on all those things. I dotted all my T's, I crossed my I's. I had a great little short harness that I made, and I couldn't get anything on my oscilloscope when I was trying just to prove out that it was CAN. I just couldn't do it, and it's because I forgot one of the most basic things. I was looking at a cable that had 6 bolts on it. There's just no way it could have been CAN. I don't know what I was looking at, but I was so wrapped up in all of these other things that I forgot the basics, that there are other electronics in these harnesses. And that's why you don't just want to go tapping like crazy without necessarily knowing what you're looking at or having an idea. What I like to do is I like to go see if I can buy the wiring diagram for the vehicle that I'm looking for. Because a lot of times the CAN buses, even the ones that are gatewayed away from like an OBD connector, a lot of times they're documented in these wiring or diagrams that you can just buy or find online. That is super, super helpful. That will also sometimes tell you the colors of wires, and then you can start kind of building up a working knowledge of tendencies of different OEMs. Like different OEMs like to use certain color combinations for certain buses, believe it or not, and those type of things. So one like side tip that I usually do is, as I kind of look at different vehicles, I build up a database of all of my findings, and I just kind of keep updating that as I go. And that has been so helpful when I've maybe not looked at a certain make in a long time, and I've got somebody that brings me one that that I know I did some work on, but I just couldn't quite remember. And then I look in my documentation and I say, oh, I just have to look for like the blue and red wire, and that's probably their FD bus, and boom, there it is. So noticing those tendencies, paying attention to the things that OEMs do. A lot of you work at OEMs, a lot of these things are kept the same for tooling purposes. You can use those things to your advantage. Let's see, still not seeing any traffic. Do remember, it might have taken you a long time to tap that vehicle or find the CAN buses. I'm guessing you might have disconnected the battery, which would be a smart thing to do while you're initially poking and prodding. By the time you're actually looking, is it possible that the module's asleep or the whole vehicle's asleep? You might have to reconnect the battery to get the vehicle to talk again. Or, if you're looking at, say, like a massage controller or something like that, do you need to actuate the massager before that module even wakes up? Like things like that. So be aware that there's a lot of reasons why you might not be seeing traffic, and it's not always that you connected poorly. A lot of times vehicles are, especially modern EVs, I've seen, it's like a lot of these things haven't been sorted out yet. But once you disconnect the battery, it takes some weird things for certain things to work. So I was working on an EV earlier this year, and we found that if you disconnect the high voltage and the low voltage, which we wanted to do because we were really going to be poking into some cables and things like that, we found that if you didn't not only turn the car back on and disconnect the charger and drive the thing, that you couldn't use the AC at all. Like it was impossible for you to turn it on. So you could press the button in the infotainment or in the center stack and nothing would happen. Until we actually drove it for a minute. It's like it allowed that ECU to come back on, and that's what we were after. We were literally just looking for the AC bit to flip. That's it. That's all it was. So I've seen weird things like that, and it's important that when you run up against a wall, that you don't just shut down. That like you don't think, oh, this must not be CAN. Like build up a routine of things that you're trying so that you can make sure that you're giving yourself the best possible chance for success. So if the module is not talking, is there any voltage going into it? Use your multimeter to kind of figure that out. Like maybe something's just not turning this on. When it is on, is there something that you can usually hear in it and you can't hear anything anymore? There's all kinds of small little things that you can do to work on these things, but don't rule out the randomness, like the weirdness. Like not all vehicles are built to be tapped like this. So like sometimes you're introducing situations that really haven't been accounted for in the design process, or at least that's how I feel. I'm not a vehicle designer, but I can imagine people that are kind of designing these modules not really imagining the weird the weird order in which that I'm doing things. So sometimes you're introducing these corner cases that haven't been accounted for. So it's another kind of word of caution. Don't be aware that these things can happen, and it's another reason why you don't just take your daily driver and just rip open that harness. It's not that easy. Plus, it's not real hard to properly seal it again. So cars that are designated for this, always the way to go. So next slide here is just a brief touch on OBD, revisiting simpler times, as I put it. OBD used to be a lot more useful. As people have become more interested in competitive data for a number of reasons, OEMs have kind of wised up and have started to pull things away from that, maybe by not populating all of the pins on it that they used to. There are a lot of vendor option pins on OBD that were used in the past that aren't used anymore, but also by the use of gateways or a module behind the OBD port that's managing all that traffic, that's looking for the right requests before it populates anything on that bus. So when you're just looking at traffic on a CAN bus through OBD, you're looking at what I call, or what is called normal mode traffic, just stuff that's just on the bus. It used to be that most vehicles, there was just a plethora of data that would just be available on OBD, and that's changing. That's not to say that if you plug in on certain vehicles, even modern brand new vehicles, 2021, 2020s, these type of vehicles, that some OEMs still put a whole lot of useful information on there. And beyond that, if you're familiar with J1979, a lot of the signals that a lot of my customers need things for benchmarking purposes, like just things like vehicle speed or coolant temperatures, things like that. Those are PIDs that can be requested through J1979 requests. We actually have an example file that I've used over and over again. So, I'll have a customer that like is just like beside themselves because they can't find wheel speed and, or I'm sorry, not wheel speed, but a coolant temperature. And they didn't think to just maybe try asking with a scan tool, that maybe the scan tool can just get that data and they don't necessarily need it from a specific module. They just need to know that it's there. So don't rule out J1979. Those requests and those PIDs, they can still provide a lot of data. Now, if you're looking for, battery data like cell voltages, individual cell voltages or temperatures and things like that, obviously J1979 is not going to have all of that unless an OEM went through a lot of effort to code that in, and you did a custom request and you knew the parameters to look for. It's not something that's generally going to be on J1979. And then some OEMs have removed the OBD connector altogether. To just briefly touch on the question that I see in the chat, obviously for emissions purposes, there's a lot of stuff that's still legislated to be on J1979, but when you move into pure EVs, a lot of that has gone away. And like I said, without mentioning any names, certain OEMs have done away with it by now altogether because it's the writing's on the wall kind of for it. So that makes them a little bit more difficult to tap, but they still use CAN, so you can still find it. J1939, little different. I would say J1939, no comments on any of that from me, but J1939, a little bit different. I find that a lot of those trucks aren't even putting anything on those connectors anymore. So it's more about finding CAN and tapping it and things like that. So at least that's in my experience, and that's with very new trucks. I don't have a ton of experience on older J1939 trucks. Just to put that out there. Yeah, I'm not going to say who removed it, but you can Google it. If you think why, it makes sense, but I will say it makes it a little bit more difficult for dealers, right? Dealers don't have necessarily that same connector that they've always been used to. So there's different requirements now for getting into those type of vehicles. That's not to say that those OEMs aren't held to the same standards with regards to that data being available for their dealers, but it's just different, right? It's just something else that you have to account for. So I'm going to try to speed up a little bit so I can make sure I get through everything. But some of the tools that I use. So shameless plug for Intrepid control systems, but I use a Neovi for most of mine. I use a Neovi Fire 2. Pretty soon what we have called the Red 2. But you want a network analysis tool. A data logger makes it easier, right? So you can set your logger up to kind of log all of this data and you can review it later. Why a data logger is valuable? How about trying to reverse engineer while also driving a car if you're doing this alone? Next to impossible and also extremely dangerous. Don't do that. So having either a second person or a data logger and then doing post analysis. If you go the data logger route, it's important to have something that like some sort of trigger that you can kind of like tie to the data so that if you do something like let's say you hit like a real high rev limit that you wanted to see in the data, you can press a button and mark it, those type of things. That's what a logger would be good for. But we need a network analysis tool. We need something that can talk to the CAN bus, right? So that's the start. Vehicle Spy 3 Enterprise. The Enterprise version is what you want for reverse engineering tools. At least the features that I'm going to cover here, definitely the Enterprise version. But we need some kind of software, right, to talk to to visualize the data. If you're unfamiliar with Vehicle Spy 3, the real quick and short and dirty definition of it is going to be kind of like a Wireshark, but for automotive networks and with more tools for interacting with the data. So things like panels to visualize the data and things like that. So beyond that, one of the most common questions that I get are piercing and contactless wiretaps. that question I see in the chat about the difference between Pro and Enterprise, on our website, there is a comparison sheet. If you actually just Google Vehicle Spy comparison, you'll get it too. But it's just on the website, and then I'll add it to the chat when I'm done. Anyways, so wiretaps. Piercing wiretaps are the cheapest option, but even from Amazon, I'm warning you, and I just grabbed an image from Amazon for these. I've used these before, they're cheap. I'm warning you, cheaply made. They're still actually kind of expensive. So I find 2 packs on average to be like $20, $30. They're way cheaper to order through a reputable supplier like Molex, or TE makes some. But what's nice about these, what I'm looking at, I don't think you can see my cursor, but I'm looking at this pair of 2 little stick looking things on the screen. What's nice about those is they've got the banana plug ends on the other side. So you can, it's just really easy to then build cables and run twisted pairs off of those. These are cheap, but they are piercing. So they're going to pierce that jacket on the cable, which, like I said, full disclaimer, you're now modifying your car, and that jacket serves a purpose on that cable. So do be aware that opening that up does introduce maybe the chance for some more noise, definitely contaminants and things like that. But let's assume that this vehicle will never be driven again. Piercing contacts are great because it's very quick. So you just stick these things on, and then assuming your network analysis tool has like the right baud rate, and then maybe you need to provide termination. Another shameless plug, a lot of neobuys will provide software-enabled termination for these type of things. It can be really quick to just hook up, look in vSpy, and if you're not seeing anything, to flip them to see if you got the high and low mixed up, or use a multimeter to see which is the high or low. So as far as the clips that I use, I try not to provide them because I'm generally not providing the vehicle. So most of my customers I've seen, they use the cheapest ones that they can find on Amazon for this purpose. I really don't recommend that, especially if you're going to tap CanFD. They make really nice ones that you can order in bulk, like I said, from Molex and things like that. They're great. And then the other option, and I've not explored this too much, but I'm very interested in it, is these contactless wiretaps. So there are companies that make these induction-based contact-free clamps that you can put on CAN bus. And I have seen it tap CanFD, which is just amazing to me. They're not cheap devices, but if it's your job, it's definitely worth the money. If you're interested in that, I don't want to plug the company that makes the one that I've used before. Just send me an email or a Q&A or something like that, and I can talk more about that. But they're really nice. It means that you just have to open up the harness and you don't actually have to pierce the cable, which is super cool. It makes it really easy for just like throwing it on a cable and seeing if it's CAN without having to pull out your scope or anything like that. They're great, but they're pricey. Like you're not constantly buying new clips as you break them though. So it's up in the air, you know what I mean? If it's your job, then I could totally see the money being worth it. Other things that I use all the time, a good scope is priceless. Well, it can be priced, but for this purpose, I consider it priceless. I use them all the time, especially if I'm, like I said, looking at maybe a CanFD bus and I can't figure out why it's not working. I try to just use maybe an oscilloscope just to see a voltage. Like I said earlier, I wasted a whole bunch of time looking at a 6-volt line earlier because I was paying attention to everything else and I wasn't looking at the basics. Is this the right voltage? Multimeter can be good for that. The image I include has a clamp style multimeter, which I think is super helpful. I've seen Fluke multimeters that have small little tiny wire sections in the clamp, so it'll hold the wire real nice. They're super nice. But multimeters are really helpful, not just for looking at CAN, but for like checking to see if a module is getting power that you expect it to, or using it as a reference point for measuring something else. There's a lot of reasons why a multimeter should be in your tool bag, in my opinion. And then other cable tools. So things like maybe you want an OBDY splitter. One great thing that you can use with a splitter. So let's say you've got a test tool or a scan tool, right? Maybe you bought it on eBay, or it's just a normal like Innova scan tool, right? That you might have bought at AutoZone. Throw an OBDY splitter on it, and then put a network analysis tool like a Neovi Fire 2 on the other end, and you can actually snoop on the traffic and learn a lot of node addresses, or what's out there, what you could potentially follow from that OBD port. It can be super helpful to do that. I've seen people put data loggers in their vehicles and then send them in for service, and then the dealers have tools that they didn't have, and they just put them through the OBD port, and then they logged that interaction, the security exchange, and everything. I thought it seemed so obvious after the fact, but it was pretty brilliant. They got all kinds of cool data from that. But beyond that, like I was saying with the OBD port, sometimes you can just follow the wires back, and that's how you can find your modules. So if you're looking for an ECM or a transmission control module, you're not seeing any of that information normal mode just on OBD. Why don't you just try following that back to the gateway module and see if you can trace it from there. Like I said, there's a little too many questions coming through the chat. If you submit them through the Q&A, I will get to literally all of them. I'll try to get a copy of all the chat to cover all of them, but it would be helpful if it came through the Q&A. And like I said, I'm looking for the Q&A to help shape the future courses. So now I'll spend the rest of the time going through some features real quick. I realize I've actually taken half of our time already. So I'm going to try to get through our vSpy features next. But vSpy has a lot of great features that I don't see in any other tools really for this. So I even have some customers that don't use vSpy, and they had to specifically just for this job because there was really no way to do some of these things in the software that they had. So some things that we're going to look at. This is a general kind of view of messages view and the messages editor. If you've used vSpy, those are the two views that I use the most often by far. So we'll look at column sets, different types of filters, different ways that you can control your buffer. But down at the bottom, really, I think is the gold mine. That's the reverse engineering features. That's I think that one of the things that we bring to the table that's completely unique and really allows for this to be something that isn't just painstakingly difficult and time consuming. So in vSpy, and I'll start kind of toggling back and forth, we've got column sets. So that's this screenshot up at the top. These are just different column sets for different protocols. So like I said, this course is really just focused on CAN and CAN-FD, but we've got different column sets to make looking at Ethernet data easier. LIN and Ethernet, those two alone are so different from CAN that you would really need to change your view to make it useful. So we've got speed filters. Those are on the left-hand side. This is great for either building a custom filter or using some of the network filters that we provide. But what's cool about these is in the boxes, you can just quickly toggle them on and off. And then we've got header filters that run across the top. And then here I will show you those. So if you can see vSpy now, just up at the top here, we've got our header filters. And what's really unique about this is you can actually filter down by data bytes, which is really handy. So if you're just looking for messages with that, regardless of RBID, I can look for that. So as I was alluding to earlier, if you maybe know the data byte structure but don't know an RBID, well, here's a way that you can just kind of search for that message. Beyond that, so we can delete that. If I wanted to just filter by a certain network, which I could do just by including it there. If I wanted to exclude it, I could exclude it. I only have one network here, but these are quick filters. You can build custom filters here by pressing this button and going through and adding different messages. So let's see, I've got one message here. I could add this here and press OK. And I could just enable my own filter that I built there. So here's my own signal that I filtered by. And I could just turn that on and off. Or I could include like all of something and then also just include or exclude that message. super helpful, especially as you go on and as you get further into the process. Column sets are at the bottom here. Excuse me one sec. So like I said, if this was Ethernet data, I could pull this down and switch it over to Ethernet, which will not make any sense for CAN. But if what you're doing is Ethernet, which a lot of modern EVs are running Ethernet almost exclusively, that would be great. That would be super helpful. You could see things like source and destination address, things that are pretty darn important on Ethernet. Let me switch back to the PowerPoint. There we are. So next up, we've got some buffer controls. Pretty simple, pause, save, and erase. I'll go into vSpy to show save real quick, but pause is just going to pause the buffer. One thing to be aware of, if you pause, Vehicle Spy 3 is going to keep collecting data, which is pretty important. So don't expect it to stop that, which means if you've got something important in the buffer, make sure that maybe you're saving it or something like that, so you don't get carried away while you're paused, because the buffer is a finite amount of space, and you don't want to fill that up and lose your data, because the default behavior for Vehicle Spy is to overwrite the oldest data first once you fill that buffer up. Erasing will just erase the current buffer. Anyways, if we go look at save, you can kind of see a lot of the different formats. So if we just hit save, we can save that buffer, but we can change the format. Next up, we've got scroll and collapse mode. These are very important to understand. So it's a scroll button, which kind of just turns scroll mode on and off, but I call the off mode collapse mode. Really useful. So what scroll mode will do is show every single individual message on the wire as a unique line, which can be helpful, especially if you've got a quieter bus and you just kind of want to see how everything's working in real time. But collapse mode, I think, is really the most important one. That takes like ARB-IDs and collapse them into one line, so you can have a better kind of look at the entire bus without it scrolling infinitely fast to where it's not helpful at all. So just to give you an example here, this is collapse mode, where we've got a single ARB-ID like 381. If I just filter by that as one single line, but if I take scroll mode off, I see every individual message. And this can be really helpful, like I said, especially if you're filtered down to your message and you want to watch this data change and you want to kind of have a history in your head, or maybe the data is slower. It could be really helpful. So also in messages view, we've got data byte formats. I would advise sticking to hex, because for the most part, hexadecimal is what everything is kind of developed in. So it's kind of the way that you're going to want to understand the vehicle anyway. It's going to be in hex, but you can switch it over to like decimal, and there's a couple other options here I could show you here. So if we move back over to vSpy. I'm going to remove my filter here first, but I could switch this over to decimal, and then maybe I'm pretty close to what I'm looking for, but I just need something visually to kind of make a little bit more sense to me. I could switch it over and I can look at it this way. I suggest sticking with hex, and over time becoming better at learning to read it quickly, because it is like I said, kind of the native format that you're going to be looking at. Can you filter on 2 frames at the same time? Oh yeah, absolutely. Not only that, really as many frames as you want and as many signals as you want. So like a vSpy basics course would go into a lot of detail about that. I'm not going to go into too much detail because I want to get to the reverse engineering features here. But absolutely, you can filter pretty much any way you can think to. So, let's go back here. So message statistics, a lot of people don't know that button's down there. What this is going to do is give you a lot of statistics for on the message level, things like min, max, standard deviation, change counts, a lot of time information. A lot of people haven't seen that button, and it's right down here. So I can, at any point, just press this button down here, and I can see all kinds of statistics about these. And I can filter, like I said, down to 381 and just view the statistics for a certain message. One other note about this, if I create a decoding for this message and I've got a signal that I want to see this stuff on, I can plot that signal and plot different values for that signal. So instead of actually looking at maybe the value of the signal, I can plot like the min and the max and the standard deviation and a lot of different information about individual signals. I just need to create the decoding for that first and then do that. So if you're interested in something like that, let me know, ask a question about it, and I can definitely send you an email that kind of shows how to do that. But that's another thing that would be covered in the vSpy Basics course, or even into maybe our scripting courses, things like that. But yeah, I know that was a very busy screen, but you can filter down on one. You can also comma and filter by 2, however many you want. Once you've filtered here, you can also then enable speed filters. A lot of different ways you can filter data. All right. So what do those squiggly lines mean? That's the next thing I'll cover real quick. That's raw versus decoded data. So when you're looking at that red squiggly line, that tells you that there is nothing in the receive table or the database table that is matching that message to decode it. So that means you're looking at raw data. So what that kind of looks like in vSpy. So these messages that have green, that is because in the messages editor, I have entries for these. So I could change like this to my message 1 and my message 2. And there they are, green. And then once they're green, I can actually expand and see signals if I've got those called out down here. So that's the difference. So when you're looking at this, if you think you've got an idea on kind of what this frame is and you want to start trying to play with the decoding to see if you can get it right, you can right click on that symbol right there and add it either with or without the data section. And what it means by data section is these data bytes. So if I take a message I haven't added, like this B5 message, and I add it without the data section, and then I go over to the messages editor. Here it is. So I could change the name here. My message 2 or 3, excuse me. And then here we are. Now it's green. I didn't define a signal, so I don't have a little plus, but that's kind of how that works. So that's a start for building your decoding. So it's really important to understand what these things mean. After that, I'm going to quickly jump over to the message editor and kind of go through some of the important features in there because it's real important on understanding this. And then like I said, adding a message to receive with data section is going to just take the current data bytes when you clicked on it. So I mean, I could show you what that means real quick. So for example, this B4 message. If I go to add RX with data, it's only going to decode when it matches all of these data bytes and it adds that into the message editor. So now all of this is required for this decoding to work. You can edit this as you see fit, but it would, you would add this if you're looking for decoding a very specific data byte stream. Anyways, live edit. Well, we're gonna, like I said, the reverse engineering features that we're about to get into kind of depend on a base understanding of these features. So I apologize. That's why I'm doing more than one of these. This is really to kind of create a recording to lay a baseline so that we can start getting into more detail. But if I just jump into the reverse engineering techniques without explaining how these features work, I think it would be a little difficult to understand. So I appreciate the feedback, but that's kind of what I'm building to. Anyways, in Messages Editor, we've got a feature called Live Edit, which I'm just going to kind of jump into in vSpy, but this is really where you start reverse engineering, in my opinion. So what it allows you to do is change the decoding live while you're looking at the data. So you can see how your decoding affects the data. So like as you add different scaling factors and things like that, you can see how it affects the data. So that's in a lot of people's mind, that's the biggest challenge that they have with this. So if I head over to bSpy, what I mean by this is, give me one sec. This will be a good one here. Okay, so as I look at this message here, when I turn live edit on, you'll see that I start getting the value here, okay? And that changes as I start looking at different parts of the message. So if you're looking at a raw can frame and you don't necessarily know, like you've got a lot of data bytes moving, it's all in hex, it doesn't make sense just staring at it. You haven't necessarily written code to parse it. This is the start really of where you're gonna start trying to figure these things out. So I've created a signal, I've given it a name, and then I can play with this location. I can make it, I can move it around. So I'm looking at whole data bytes, half data bytes. I can make it a lot longer. I can make it shorter. I can look at a few bits in here. I can move this around as I see fit. And then beyond that, I can hit this edit button and I can add things like different scaling factors. So let's say I want to just scale this. I can click my live edit again, and now I've got it scaled. So you can continue to play with this, move this around, do whatever you need with it. But this is live edit. So as you can see, it has greatly affected the way that we're decoding data, but maybe I'm closer to what this actually is. Maybe they're scaling it a different way. 5. Click live edit again. And now we're looking at it in a different way. So changing these, a lot of times, something simple like vehicle speed, it'll be on the bus, normal mode traffic, but it's scaled at like 0.26 or something like that. It can be really difficult to figure out. So a lot of times it'll take plotting these signals and looking at the ramps and curves and kind of trying to figure it out this way. But being able to play with this live edit button on a signal like this is critical. I mean, maybe you think this is a status. You can change the signal type here. Instead of an analog signal, we can change this to a digital signal and actually change the way we're interpreting it. So then once we make an edit, we just press live edit again. And here we are. Digital signal is going to look at 1 bit, but I can move this right back out. And yeah, a lot of this can be coded and post-processed, absolutely. So the quick plot in message editor would be great. Yeah, there's a quick plot in messages view, which is what I'm going to get to, which is really handy, I think. So the reverse engineering features, though, this is where we're going to, this is, I think, what sets Vehicle Spy apart. So there's this backwards E here, reverse engineering, kind of clever. Excuse me, one sec here. But it's got all kinds of features that are built specifically for reverse engineers. So just to jump into the most useful one, suppress highlighting. Without suppress highlighting, certain things that take days or certain things that take me minutes would take all day to find without being able to do this, especially on very noisy buses. So what suppress highlighting does is that activity highlighting or the flashing that you see on data bytes, it will take everything that you've seen flashing and it will stop it so that you're only going to see things that haven't flashed recently flash. And you can continually press suppress highlighting until it's not highlighting at all. And that might sound not very useful, I guess, unless you think about maybe like you're about to actuate something, you're about to press something, you're about to do something brand new, and you know it's going to change, and it's probably something that hasn't changed. Yes, exactly. Things like switches and buttons and things like that, turning the AC on, or waiting to see a status when like the AC compressor turns on. If you just keep suppressing and then press something, it's going to just call out to you. So I'll kind of show you how this works. So for example, this is changing very rapidly, so it's highlighted constantly. So if I go suppress highlighting, now it's not. And if we wait, stuff that hasn't changed in a while still is going to flash. So if I continue to do this and suppress it again, and then suppress it again, suppress it again, we've got very little highlighting at this point. And now when I press a button in a vehicle, it's just going to stand out. I mean, it's going to be probably the only thing flashing. And this is simulated Formula SAE data. So this isn't OEM data or anything like that. But if like maybe you want to find the message that has the different drive modes in it. Like I was recently in a vehicle that had like a performance mode, a stealth mode, a normal mode, different things. And my customer wanted the message that contained those, just so they could know in their benchmarking software that they were in which mode they were in. Well, we just suppressed 3 times and then changed the mode, and it was the only thing that changed. It was the easiest thing to find. So it's incredibly useful. The way to undo it is just to erase the buffer. So that just kind of resets it. But that's the basics of suppress highlighting. It is just enormously helpful. I use it constantly. Highlight changing is a toggle. What this does is it grays out messages that do not have changing data. I found this is helpful for people that are actually trying to reverse engineer like the entire bus. So a lot of times there's just too much going on, and you're really like, you might know that you're looking for a frame that's not going to be changing. So maybe you're looking for a drive mode. You can't change it though, and you know that message isn't changing. So you can probably remove a lot of those different messages just by highlighting the changing data. And then we've got highlight recent. This is also a toggle. Any message that's older than 5 seconds is grayed out. So if there's no update to that message in 5 seconds, it's gone. So maybe the signal you're looking for, you know, is going to be very rapidly updated. This would be one way to kind of call that out, or those messages out, especially if you're looking at maybe not even just one bus, but 6 or 7 different networks at one time. One note about this one, it only works in non-scrolling, like static mode, where messages are collapsed. Obviously, we're looking at the same message and its rate, so that kind of makes sense. But another thing that I'll point out, and I'm going to hop over to vSpy, but the very bottom of that menu is highlighting style. That's where you can change what vSpy considers for recent and what vSpy considers for highlighting. So things like that, that's all editable by you. Like you can change the magnitudes that it looks for, and you can change the recent time. You can change what is defined, or what do you mean by highlight changing? Like what defines changing? Is it changing once every 5 seconds or once every 10 seconds? That can all be changed in highlighting style, and we'll get there. So if I hop over to vSpy, like I said, we can just press this and we go to highlight changing. And now just my messages that are changing are kind of called out. And it might just make it easier on your eyes, something small like that. Or maybe you found that you can't on this particular vehicle suppress highlighting enough to find the button you're pushing. Well, this kind of just takes away everything that's not changing. So it's going to help a little bit, right? So if you press a button, it's going to be called out here. So that can be helpful. And like I said, that's a toggle. So we can come back in here and just turn that off. We can also do highlight recent. So this on this particular buffer file isn't that great, but the recent time by default is set to 5 seconds. So my messages that are changing by 5 seconds, they're going to remain highlighted. The messages like this that like isn't coming in at all, hasn't come in a while, isn't changing, it's de-emphasized then on the screen. So different vehicles will benefit from these two different toggles differently. And then the next, well, one other thing, highlight changing obviously overrides highlight recent. You can toggle both of them at the same time, but changing data will be emphasized. Next step, I've used this a couple times. I used this once when I didn't have much time on the vehicle and I wanted to grab all the IDs that were in there because I thought it might help me identify certain modules that I've worked for in the past. But it's a toggle that basically grabs every single RFID that's not decoded and creates an entry for it without the data bytes in the messages editor. And I can demonstrate that in a second here. But one note about that, it erases the buffer completely. So if you think you've got data that you want to save, grab a save of it real quick. It's really important. You don't want to lose your data. One cool note about that too, after we do that. So if I go press my reverse E, I go auto add, it's gonna take a second here, but now you notice everything's decoded because over here in the message editor, it added a new entry for every single one. How about just saving time? Like, you need to decode all these different messages. Boom, you don't have to type all the ARB-IDs in and titles and things like that. Like, I find that one of the biggest challenges with reverse engineering is just how long it can take. Finding that perfect scaling factor that was used in the engineering of this module sometimes is really hard. So small things like this that can save time, super helpful. But the other cool thing about this is once this is done, if we just hit this save button, we can actually export this as a DBC, just like that. You can edit this and add data bytes in if you want, but boom, we've got a DBC at least that has ARB-IDs for us to work with. So if we know we got a buffer file, and we're gonna maybe be on a different computer or something like that, or maybe you've just got this file, but you're on a new vehicle that is the same or similar, you've got a DBC then that you created real quickly from it. So that can be really useful, and then you can just import the DBC right into vSpy and use it for decoding. Yep, there's just a screenshot of DBC export. Template mode, I'm not going to go into too much detail about template mode. What template mode does is it gives you a pretty quick way. Let's say you know the data byte structure, but you need to change it to different IDs really quickly. It allows you to create a template for a message. So like if I'm going to go offline real quick and delete some of these. So I have some messages that aren't decoding. Ooh, give me one sec. There we go. Anyways, what it allows you to do is you can right click on the message. Oops, sorry, skip forward on one. First, we can enable template mode. I'm going to turn that off. We can enable this. And then if I right click and I add, it's going to allow me to create a template. So I hit OK. And then if I add another message with data, I can select this ARB-ID real quick. So instead of adding the second message in that new ARB-ID 401, I can just add the data bytes to 381. So it's kind of hard to describe the usefulness of that. I found usefulness when it was a vehicle that was very, very similar to one that I've already worked with, but was just different enough to have a couple different modules. So like maybe I knew that a certain OEM likes to format, like I said, their vehicle speed a certain way. And I know that scaling, and I know that I know the bit position, the things that are important, but I don't know what ARB-ID it's on because the module is different. Template mode might be helpful for that. I personally have never used it with CAN, but there was an application with Lin that I used it in, which is, if you're interested in that, you can send me an email. There's a feature next called show all messages, even with zero length. What this does is it takes any messages that are in your received message list, and it displays them in messages view, even if they haven't showed up on the wire. They show up with a zero count. I don't think it's useful at all, personally. I've never used it, but it's there. If you think it might be useful to see those things in messages view, great. But you can just tab back and forth between message editor. I've just not encountered a situation where I've needed it, but it's important to know it's there. Highlighting style down here though, this is very important. I mentioned this earlier. This is where you can change the recent time that it's used. So for that change recent or a highlight or changing data, things like that, the recent time can be affected here. But this is also how you can change what is considered for highlighting. So you can change the magnitude of when the bytes changed. So if you want to increase that so that, well, if maybe this data byte only goes up by 1, I don't want to see it. But if it jumps up by 5, I do want to see it. Like maybe you set the highlighting to be different with maybe RPM because you don't care about the small little moves, but if it over revs or something like that, you want to know, you want to see it in the data, you could do that. And then the gradient change down there is all about the rate of how fast it's changing. So if suddenly something starts changing a lot faster, like maybe you want to know, maybe you don't have a good way of measuring your coolant temperature, but you need to know when it suddenly starts increasing, and because you've got no way to stop it. It might be a good way to do that. But yep, you can change all of these type of things in there. So if I hop back over to VSpy real quick, and I go here and I go to highlighting style, I can actually just change this just by dragging. Default though, as you can see, is any change. When any bit changes at all, we flash. The details pane I'm going to show, but this is going to be the primary topic of my next webinar. I saw one person ask when the next one is. I'm going to try to do this relatively soon, like within the next month or two will be the next one. I might do another intro one like this to people that missed this one, but I'm looking to continue this and make this a series going forward, because I could spend 2 full days going into the details pane. So I'll just hop over to VSpy and talk about this briefly. The details pane right here, if we click this, what the details pane does is it gives you a way of deep diving into messages. If we hit this reversing here, so I can select certain bits here. I can add tracking signals, which are reference points for analog values. I could add different data points to use as engineering value samples. And then I can track these signals here as they're changing. So let me find a better example. So as you can see, the plot over here, as I add maybe like a different engineering sample point, it's going to change the way we look at this data. And I can actually add a tracking signal, which I could use. Maybe there's a signal on my bus that is providing me voltage that I want to use as a reference. I can actually set that as my tracking signal as well. And then it'll use that as a reference point for what I'm plotting over here. And then there's all kinds of tools to change the way we're like looking at different axes and things like that in the actual plot over here on the right. We actually have a frequency time domain as well, which I think is super cool. I've not used it before, but it is here. We can change that axis span. We can change what bits we're looking at. We can move this around. We can change how we're looking at these signals. So if we think that might be a digital signal, I can approach it like that. But what's really cool about this feature, if I actually bring it up, you can see the whole thing. With like 8 steps, and just to give you an example, our help has all of this. Let's see if I can quickly get to it here. But what I'm going to go through in the next, hang on here 1 sec. What I want to find is, I'll find that later. I've got basically an 8-step. If you press, by the way, if you press F1 at any point in Vehicle Spy, it opens our help, which is just wonderful, and it opens it to the view that you're looking at. But there's 8 steps that you can really use with this detail pane to really hone down on a specific decoding for a signal. And that's what I'm going to go kind of into with my next course. I could fill 3-4 hours easily on this. So it was more, I kind of wanted to just introduce it on this intro one. But the next one is really going to be diving into how we go bit by bit and build and try to figure out these scaling factors, because that I find to be the hardest thing. So most people these days aren't just going to put a coolant temperature on a normal mode message. They're going to have it like split across 3 different bytes and scaled to 0.17, all sorts of weirdness. But this allows you to kind of hone in on those things. You can add your things like units, like if you're tracking a lot of different signals and you want to add this as miles per hour, you can do that. To answer that question, in Pro, details is available. You just have to turn it on here. I think the reverse engineering features are in Enterprise, But if you ask questions about that, I'll go into all of that after this because we're already over on our time. But let me hop back over to the presentation here. So last bit, please, please, please. I noticed that some people weren't so interested in the vSpy features. For record, we had about 250 people in here, and I think that a big chunk of them probably have never seen some of these features. So I'm going to be using these features heavily as we get into the demonstrations, but I needed to lay down a baseline. So please take this. If you have questions about these features, submit them through the Q&A, and I will get to all of them. Any feedback you could provide, put it through the Q&A, even if it's not a question, if it's just feedback for me, I'm more than interested in it. This is the first time I've done anything like this. So if you've got any feedback for me or about the presentation style or anything like that, please provide it. But thank you, everybody. I appreciate everybody coming, so many people coming. Everybody that's registered on the email list, I'll send the slides out. And then, like I said, I can get back directly to you individually with all of your individual questions. So hopefully this is just a little intro into what Vehicle Spy can provide in this regard. And then going forward, yeah, I'm hoping to shape these courses based on the feedback I get from everyone. So thank you, I appreciate it. Thank you very much. I look forward to answering the questions.